Okay, let's get started then. Right, just make sure everybody's in the right place. This is a Hadoop Kickstarter for the Microsoft platform. Is anybody expecting a different talk? Awesome, we're all in the right place then, that's good. So, who here has heard of Hadoop before? Few people, excellent. Who's used Hadoop before? Nobody, awesome. This is going to be a good session. It wouldn't be the first time I've given a session. I said, who's used Hadoop before? People put their hands up. Who uses Hadoop every day? Same people. It's like, why are you here? Go somewhere else. All right. Okay, so this is me. My name's Gary Short. I am a Microsoft MVP in the C# language. I'm a freelance data scientist engineer. Basically, using those tool sets. Data science, as I've said, if you were at yesterday's talk, data science covers a broad church. It's like saying I'm a farmer. It doesn't really tell you what you do. What I do here is I specialize in three things mainly. Predictive analytics, we're not going to do any of that today. I did it yesterday. If you weren't there, you missed it. All right. I also do machine vision, we're not going to do any of that. I do some computational linguistics, we'll do a little bit of that tomorrow when I talk about troll hunting on the internet and how to stamp that out. Do a little bit of that kind of stuff there, so if you're interested in that, come along there. The most interesting part of this slide is the bit at the bottom where you can find my contact details if you want to get a hold of me or ask questions afterwards. Okay? So this is the thing that we're going to cover. These are the things we're going to cover in the next roughly 90 minutes or so. First of all, we're going to look at what problem Hadoop solves, right? Basically, what is the point of Hadoop? What is the point of MapReduce? Okay? We'll define the difference between MapReduce and Hadoop because you find an awful lot of people use those words interchangeably as if they're the same thing, okay? And they're not. Then we'll get on to the important stuff. How do I install it on my dev machine at home so I can play with this cool stuff? How do I get my C# code running on it? Who here is not a C# programmer? Okay, sucks to be you guys. What are you programming? Java. Really sucks to be you. What are you programming? Basic. Visual Basic? Okay, so everything that I'm going to talk about today totally applies to you as well. It's just that you'll use a language with a funny syntax instead, all right? But everything else is the same. Anybody who does any other languages we've not covered yet? Nope, that covers everybody. Awesome, all right. Everybody will have fun. Well, maybe not, but. And then, how do I visualize my results? Okay, because it's fine having a big Hadoop cluster to do all kinds of really cool stuff, but then at the end of the day, you've still just got a text file full of stuff, right? That doesn't really help you. So I'm not going to spend a lot of time talking about that because this is not a talk on how to visualize data, but I am going to show you one really cool tool, technically two really cool tools from Microsoft, which will help you visualize data from an Hadoop cluster very quickly, okay? Literally a few clicks and we'll be good to go. So we will look at that just because it's cool and it helps you see the data and it makes that leap from just a file full of stuff to actually something that interesting you can see. And then we'll do questions, but feel free to ask questions as we're going along. It's just that questions has to be somewhere on the agenda, so I put it at the end. But feel free to ask questions as you're going along. It's actually easier if you ask the questions as you're going along because then normally I'm actually on the slide or I'm looking at the bit of code you've got the question about. If you leave it to the end, then I've got to rummage around like an idiot trying to find the bit that you're talking about, right? And I usually can't because I'm not really that smart. But shh, don't tell anybody. All right, so demo time. Let's have a look at what problem Hadoop actually solves. What is the point of MapReduce and what is the point of Hadoop? So let's have a look at that. Let's jump along here. Okay, so here's our first bit of code. Now everybody knows the rules, right? That you have to do the canonical example for the thing that you're talking about, otherwise the demo gods smite you, right? So if you're talking about a new programming language, you have to do hello world, right? If you do not do hello world, the demo gods smite you and none of the rest of your demos will work for the rest of your session. Your entire audience will laugh at you and they'll totally slag you off in the attendee feedback, all right? So, for some reason, and I have no idea why, the canonical example for MapReduce is a word count, right? I've worked in this area for years now and never have I been asked to count words in a file. right? Nobody's ever said to me, as a data scientist, Gary, what we really want to spend money doing and pay you your day rate is to have you count words in a file, right? That has never happened. But for some reason, I guess, you know, it's not really stupid because nobody's ever paid me to write hello world either. So I'm not sure why this is the canonical example, but this is the canonical example, and it explains the problem quite well. Maybe that's why it's the canonical example. So what I've done here is I've got a string, okay, and you can see here I've been really clever. I've got the word 1 once, I've got the word 2 twice, and I've got the word 3 times, and the word 4 times, all right? And then what we do is we use a nice bit of C# code here just to split that up on the commas. What I want to do is I want to count these words. So this is quite a naive algorithm. I split them up on the commas. I group them together by word, which means it's grouped on the word. Then I iterate through those and I write out the key and the count of the group. So that's basically the word and how many times the word appears. All right, so it's a word count. So when we run this, and if I can actually program, okay, so the one word appears 1 time, the word 2 appears 2 times, 3 appears 3 times, 4 appears 4 times, and so on. All right, so that works. Woo! We can do a word count. Now, this algorithm is quite naive, all right, and it's constrained in 2 ways. So what's wrong with this code? In which 2 ways is it constrained, or one of the 2 ways it's constrained? It's like, don't ask me questions. It's right after lunch. I came here to sleep. For God's sake, you know. All right, so it's constrained, first of all, by memory. All right, so that's one of the ways it's constrained. It's constrained by memory because what I do here is I load in this string, okay, into memory, and then I process it. All right, so if you're standing there and you say, well, what happens if, you know, that input doubles? All right, and what happens if it doubles again and again and again? At some point, you're going to run out of RAM on your machine, the machine is going to fall over. All right, so we're constrained by memory. This algorithm is constrained by memory. So to get round that, we'll say, well, actually, we won't load that string into memory in one go. What we'll do is we'll put it in a file and we'll open a stream on a file and we'll stream it in 1 line at a time, and that means we're no longer constrained by memory. And that is true, but if I'm here again and I say, well, what happens if you double the input? You say, well, it just takes longer. And what happens if I double the input? Well, it takes longer. And at some point, you say, well, actually, it's going to take 3 days to come back. Now, that is no use, right? You can't set something off and come back 3 days later to get the answer, okay? So we're actually constrained. The second way we're constrained is we're constrained by CPU as well, all right? So this algorithm is naive, it's constrained by memory, it's constrained by CPU. So we need a way around that, all right? And Google actually had the same problem back in the early days when they were indexing the internet. It turns out that indexing the internet, you can't just buy a big box, load it all into memory, okay, and index it, all right? There was a point where you could do that, right? There was a point where you could do that. In the very, very early days of the web, Tim Berners-Lee used to have a machine in his office, right? And stuck to it was a piece of paper. It said, do not switch this off. This machine contains the internet. Right, literally, it was all in one machine. But those days, right, are long gone. So Google had this problem, and what they did was, very smart people at Google, they invented the MapReduce algorithm. And what it does is it takes any algorithm like this, and it turns it into 2 parts. One part being a map, one part being a reduction, okay? And so we'll look at that solution right now. So we're going to use exactly the same algorithm, all right? So here, I'm actually just loading in, I've done the same thing, we've got exactly the same string there, all right? And I do a map on it, and then I do a reduce on the output of the map. So, let's talk about a map. What is a map? A map is a function which takes in any string input, okay? So that's anything that can be defined as a string, so anything that you can serialize down to a string. It takes in a string input, and what it does is it outputs a tuple, okay? Where with a key value pair, all right? Now that key and that value can be anything, okay? But that's what it outputs. And then what happens is the reduce then takes that output, okay? And it takes all of the mapped outputs with the same key and reduces that all down to 1 value, okay? So it's a bit like, it's not exactly like this, but a good way to think about it is in SQL terms, is a select followed by a group. Okay, that's one way to think about it, is the map being select me some data and group saying and group it together. All right, so it's not exactly like that, but it's a good way to think about it. So in this particular case, because we want to count words, what our map does is, here's our map function, it takes a string input, and look, you can see it's exactly the same It's not exactly the same, but it's a very similar algorithm to our naive algorithm we've got in here. We do that same split, we iterate over each of the words just as we did before, but this time instead of counting them, what we do is we output the word itself and the integer 1, so that's going to be our output. So basically what our map function is doing is it's looking at a stream of words and it's going, I've seen that word once, I've seen that word once, I've seen that word once, I've seen that word once. Okay, that's all that's doing, and that's all our map function does. All right? Now, the reduce function then gets that output. And what that reduce function does is it takes in that list of tuples, okay, and it groups them again by the word, okay. So what it's going to get is it's going to get a word, so say the word the, and it's going to get the word the followed by a string containing 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right, for every single time the map thing has seen that. Okay, and then it's going to see the word will, and it's going to see 1, 1, 1 for every time the word will appears in the document. And what it's doing there then is it's grouping then on the actual word, and then what it's outputting this time is, again, it's outputting the word itself followed by a count of how many ones there are, basically. Okay? So it's very much the same algorithm. So let's run that and see if it works. Let's select that project, make that startup project, and then click over here and then launch that. And that works. See, so we've got exactly the same output. So it works. But now the difference we've got is that we have two functions. Each can be loaded on to commodity machines, okay, and a number of machines. So we've split up that algorithm into two functions. Two functions are completely independent, okay, we can load them on a number of machines that we want. So now when I stand there and say, well, what happens if that input doubles? I'll just say, well, I'll double the number of machines I've got. Well, what happens if the input doubles again? Well, I'll double the number of machines I've got. And we can do this all day, okay? So now we're no longer constrained by memory nor by CPU, because every machine, once it reaches that constrained level, will just add 2 more machines. Okay? And we can stay here all day then going, well, what happens if the input doubles? Well, I'll double the number of machines. What happens if the input doubles? So we've solved that problem, okay? And that is MapReduce. That is the problem that MapReduce solves, okay? It's a problem of what happens, it solves the problem of what happens when you can no longer scale vertically. All right? There comes a point where your input doubles, you can easily throw a bigger CPU at it, throw a bigger, more memory at it, but there comes a point where you can no longer put more memory or more CPU in a machine, so you cannot scale vertically anymore. And what this does is allow you to scale horizontally. So it solves that problem, and that's what MapReduce does. So let's go back to our slides. So that's excellent, we've solved that problem. But actually, all we've really done is just swap one problem for a new set of problems. So we've not really fixed anything. We've just gone, well, we don't have that set of problems, we've just got this set of problems instead, okay? So the new set of problems that we've got is this, well, it's okay for me to say, we'll just take that output and we'll just put it on a set of machines, and we'll take the two functions and we'll put them on the machines, and that function will just be working with a local copy of the data, okay? And then when that input doubles, we'll get 2 more machines, and we'll put those MapReduce functions on those machines, and we'll split down the data and we'll put that on the other machines. But you're responsible for all of that, okay? You're responsible for commissioning the new machines. You're responsible for making sure that the functions actually made it to those machines, that they're up and running, okay? You're responsible then for segmenting the data up into 2 halves, and then 4 halves, and then 8. Okay, well, not the 8 halves, but you know what I mean. You're responsible for all that, and if all of your machines are running and they all do the map function, okay, and then 3 of them fall over before the reduction is finished, you're missing data. It's your responsibility to 1, work out that happened, 2, work out that you've got missing data, 3, work out what the data is that's missing, 4, spin up new machines, 5, put that missing data back on there, 6, run those applications, 7, amalgamate all that data back together again, right? That actually sounds like way more work than the problem you had before, okay? What you actually want is a framework to manage all of that for you. So you get MapReduce to solve that problem. MapReduce itself gives you a whole new set of problems, and what you want is a framework that will lift all that responsibility off your shoulders and let you concentrate on the problem that you set out to solve. And it's that second thing that Hadoop does, okay? Hadoop provides the framework to manage all of those new set of problems. So there we've accomplished the first thing on our agenda, which is to explain the difference between MapReduce and Hadoop. MapReduce is an algorithmic solution to a vertical scaling problem, and Hadoop is a framework which lifts off all the problems that come with that solution off of your shoulders. Okay? So this is how Hadoop works. And unfortunately, I left my pointer and slide advancer at home, so we're down to pencil. I'm really lost without it. So this is how Hadoop works here. And they're going to kick my ass for the video now because I've moved away from the microphone. So everybody watching on the video, you're not going to hear this bit, right? This is a secret bit. All right? So this is how Hadoop works. Over here, Hadoop takes an input, right? And it takes pretty much any kind of input, to be honest. All right? Provided that you've got a chunker that can deal with your type of data, and we'll get to chunkers in a minute. All right? It takes any kind of data, but for the purposes of this, we'll just assume it's CSV data. All right? And what happens is you say to the name node up here, this is called the name node, you say, I want to store this on HDFS. Now, HDFS is the Hadoop distributed file system. And what the Hadoop distributed file system does is it gives you an abstraction over what's really happening. Okay? Now, it's a bit like your hard drive on your laptop, right? Everybody's got a laptop, everybody's used to taking hold of their laptop and doing a dir and getting a list of the files in that directory. It said, this directory contains these files, right? We all understand that's a lie, right? We all understand that that directory structure and those files, they do not exist in that form anywhere on your machine, right? Your machine just lied to you. What happens is when you save a file, the operating system has to look around for spare bits of the hard drive and goes, right, we'll put that bit over there, and that bit over there, and that bit over there, and this over here. And when you ask for it back, it joins it all together and gives it to you, right? And when you do a dir on a directory, and it says, this directory contains these files, it's a lie, right? The name node here does exactly the same thing, okay? It provides an abstraction over a distributed file system instead of just a file system on your hard drive. And that distributed file system is in all of these other worker nodes, which could be anywhere in the world really, but preferably not, but will be in your data center. Right? So what happens is you take one of these files, you put it to the name node, and you say, I would like to save this file, please. Okay? And the name node says certain. And by default, what it does is it then chunks that into 64 megabyte chunks. Right? A chunker does that. Now, unless you specify your own chunker or one of the chunkers that are available, what happens is the default chunker assumes that you've got a text file, and it will just chunk it at the end of the line. And it'll go down enough lines to make it roughly 64 megabytes, and at the end of that line, it'll go, right, that's a chunk. Okay? If you want to chunk things like video and stuff like that, and you want it to be chunked into 100 frames bits, if you can't find a chunker out there on an open source data for you, it's up to you to write that chunker, and you just swap it in to the pipeline. Right? But by default, that's what you get, 64 megabyte chunk of data, and the name node says, right, the name node will save that file one time, that chunk one time, and it will replicate it twice. Okay? So it'll save that to one of the worker nodes, right? It will then replicate it one time onto a hard drive of a worker node in the same rack as that one. So that gives us machine redundancy. Okay? If one of the machines goes off, another machine has a copy of that data and will carry on the work as if nothing had happened. Okay? The second time it will get replicated, it will replicate it on a node in another rack. Okay? So now we've got rack redundancy. So even if you lose the entire rack of servers, there's still a copy of that data someplace else doing the work. Okay? The name node then will detect that that piece of data is then under-replicated, and it will replicate it either once or twice more, depending on what it was that went down, whether it was a server or whether it was a rack. All right? So that's how getting data on there works. Querying works in pretty much the same way. You say to Hadoop, okay, here is my map function, here is my reduce function, okay, and here is the data that I want you to work on. Okay? And then what happens, and by here is the data, you don't actually give it the data, what you say is, and it lives in this directory, bearing in mind that we know that that's an abstraction, it's a lie, okay, but we'll say, in this directory is the files that I want you to work on. And what happens is exactly the same thing here. The name node then says, right, what I need to do is I need to put that mapper up there, I need to do that work, okay, and while that's running, if one of the servers goes, what happens is, the work is done on all three of the replications at the same time, and first finish wins. Okay, and so if two of your machines die, then obviously the third one is going to win. All right, and that is how Hadoop takes all of that heavy load off of your shoulders of actually managing the MapReduce solution. Okay, do you have any questions so far? Nope. Either I'm awesome at explaining stuff, or we're all still tired after lunch. Okay, because that was a bit cartastic, that lunch. Who had sticky toffee pudding? Yes. Who had 2 portions of sticky toffee pudding? There we go. All right, how goes the time? All right, not too bad. So, this is how MapReduce works. Here's the mappers up here. The mappers, as I said, take an output, and if we're looking at the canonical example of a word count, and what happens is each of those, this mapper here might say, well, here's a word there, here's a word we, here's a word then, here's a word next. And this mapper is doing exactly the same thing, and this mapper is doing the same thing. And when those mappers say, I'm done and I'm finished, okay, what happens here is a thing called the Hadoop shuffle. Okay, which is the new kind of dance, right? You will see it on Strictly soon. Yes, sir?
The top box, the pale blue and node 1, does that hold the same input? Just go through a different mapping process?
Here?
Yes. Is that the same?
Yes. So all of these, this has a 64 megabyte by default, a 64 megabyte chunk of your data. This is a 64 megabyte chunk of your data. This is a 64 megabyte chunk of your data. And they're all running the same map function. It's why we can have Hadoop clusters built with commodity machines. Because at the end of the day, all you're ever asking one machine to do at any given time is to work with 64 megabytes of data that it's got locally in its own hard drive. Now you don't need a big beefy machine to do that, right? It's only 64 megabytes in size, it's right there on the hard drive, right? You can do it with commodity machines, okay? They all have, this, node 2 and node 3 will have different 64 megabyte chunks than node 1. Well, unless it just so happens that they're the replicas, they could all be doing the same one, right? But for demonstration purposes, they've got different 64 megabyte chunks, but they are running the same. Map function. When they're all done, okay, the first thing that happens is a kind of local reduction. So here, if a mapper knows that it's got a whole bunch of the word this, instead of going the one, it'll just do the 3. Okay, depending on what your reduction says to do. Because it actually, unless you write, you do have the option to write a specifically separate combiner, right, if you wanted to do something else. But 9 times out of 10, you want the local combiner just to do the same thing as your generalized reducer. So you just specify the reducer to be the combiner here. So instead of doing that, it would add them all up, okay, and put them out here. Then what happens is, all of the mapped outputs, all the outputs from the same mappers with the same key go to the same reducer, all right? And that cuts down the amount of cross-network traffic, right? Because this is the only time we're shunting data across the network, right? When we move from the mapper to the reducer, all right? So we want to cut down the amount of cross-network traffic by sending all of the mapped output with the same key to the same reducer, all right? And that gives you the one clue as to what is the quickest way to break a Hadoop cluster. Anybody see from that what is the fastest way to break an Hadoop cluster?
Everything has the same key.
Exactly, global key, right? Like a group by star, right? Don't do that, because then what happens is everything goes to the one cluster. Everything goes to the one node. So if you've got a 1,000 node reduction cluster and you have a universal key, then what happens is you've got one node working its little socks off and the 999 of them just spinning their wheels going, I have nothing to do, right? And you're wondering why your MapReduce job now takes 3 days to finish, right? That's why. Don't do that, your Hadoop administrator will get upset with you, right? Much like your DBA gets upset with you when you use global keys in a group by clause, all right? Don't do that. Then all of these reducers then put out reduction, the actual reduction output, which then you can then pack together to get your final answer, all right? And that's how MapReduce works, all right? So this is how that is MapReduce, that is the solution. Hadoop is the framework that allows you, that makes all the problems of MapReduce go away, and that is how Hadoop actually implements MapReduce, right? So that's the 3 things there. Yes? Yes, all three goes. So basically what happens is the name node, it's like a giant race, it's like a giant cross-country race. Everybody stands in a big pod, right? And the name node goes, on your marks, get set, go. And first finish wins, right? It's as simple as that. Because Hadoop has got no really idea. I mean, we could be almost finished and then I fall over and die, right? So if I got halfway through and the name node said to you, oh, don't bother, right? And then just before I finished, I fell over and died, then you would have to go, oh, damn it, right, go on, no, do it, right?
That's quite a lot of extra work that's being done.
Well, not really, because it's not a lot of extra work, because you're paying to have that node plugged into your internet anyway, right? The amount of money that you serve just because the CPU and the RAM and the disk isn't spinning is absolutely tiny, right? So the fact that you're being asked to do work, right, is not really a huge problem. You want your cluster running flat out all the time to make it to good value for money, right? So it's either doing one job really quickly and effectively, right? Or if you've got a really big cluster, you can do multiple jobs at a time. All right, by kind of splitting the cluster up and saying you do this bit, you do that bit. But yes, everything is working, and then first finish wins. It's faster than that. It's faster to do that than having to say, well, actually these bits failed, so I need to go to the replication and ask that to do the work. It's just much more efficient. Yes.
So the instrumentation to determine if one node is always quicker than the other.
Is there instrumentation which will tell you if one node is quicker than the other? So, if all your machines are the same, right, one node won't be quicker than the other because it's doing the same amount of work, okay? If the machines are not all the same, the faster machines will finish faster and you don't need instrumentation to tell you that because you made them faster. But there is, yes, there is all kinds of instrumentation around this, right? So it'll tell you for every machine in your cluster, what the CPU usage is, what the memory usage is, mostly around failure, to be honest. It's mostly around, this is how many disk fails you've got, this is how many read fails, how many write fails, all this kind of thing. This is how many nodes in your cluster have died. You probably want to go and fix that. So there's loads of instrumentation around that.
Is a dead node common?
Is a dead node common? What an excellent question, right? So the question is how common is it for nodes to die? So here's a good example. The mean time between failure of a hard drive is roughly 3 years. Okay, so that's roughly 1 in 1,000 chance. Okay, every time you switch on your laptop, there's about a 1 in 1,000 chance that hard drive will die. Right? I can live with that. 1 in 1,000 every 3 years having to replace your laptop. Yeah, I'd probably do that anyway. And that's fine for your laptop. But if I've got a 1,000 node cluster, I've got 1,000 machines, and the probability of a hard drive failure is 1 in 1,000, and I've got 1,000 machines, the probability on any given day of a hard drive failure is 1, which is certainty. So on any given day, if you've got a cluster of 1,000 machines or more, on any given day, you're pretty much guaranteed to have at least one node fail. If you've ever been to a data center, you can see interns wandering around with shopping trolleys filled with hard drives, and that's all they're doing, right? Is replacing hard drives on dead machines because it happens a lot, right? And a 1,000 node cluster is quite a medium-sized cluster. So yes, if you own that cluster, pretty much guaranteed to have a machine go down every day. Anybody else?
Do these kind of questions highlight the context shift you have to do in your brain if you want to move to stuff like this? Because obviously thinking in those terms isn't, if you don't work in this kind of world,
if you're not,
then you don't think in those terms.
So no, it doesn't. As a developer, this is all completely hidden from you, right? I'm explaining to you at this point what the point of Hadoop is. Okay? Well, the point of Hadoop is that you don't have to think about that because Hadoop takes care of that, right? There's all kinds of instrumentations that your DevOps guys will be looking at, and they'll be told when nodes have died. The Hadoop framework will make sure that you as a developer don't notice that they've died. The ops guys will know that they've died. They'll send out people to fix those nodes, and it'll all be completely transparent to you, right? You will not know about that at all. So, if you care, this is how it works, right? But if you don't actually care, you don't need to know. All right? Which is why I love Hadoop, right? Especially if you're spinning them up on something like Azure, right? If you're spinning it up in Azure cluster to do a job and then taking it down when it's finished, right? You definitely don't care. It's like it's just a check that you're writing to Microsoft, right? For the hire of kit, for that particular time. You spin up a cluster, you say, I want 1,000 nodes, I want to do this job. It says the job's finished, you go, thanks very much, and you shut them all down, right? And how many nodes failed there, and how many Microsoft employees in the data center in Dublin had to run around fixing stuff while you do not care, don't care, right? If it's your own cluster, then maybe you care. But if you're using Amazon services or Azure or something like that, don't give a monkeys. That's what's called an SEP, someone else's problem. Anybody else? No? Okay, so let's crack on a bit. Right, it's fantastic. How do we install it, right? We're talking about dev purposes here, right? So I'm talking about installing it on your machine. So obviously you're not going to get a cluster, right? What you're going to get is something that pretends to be a cluster, but is really just working on your machine. But it allows you to test your code, it allows you to play with it before you actually put your stuff on proper clusters, okay? So it's something you can do on the train or, at home. So how do I install it? What you do, first of all, is you use the web platform installer. Who's heard of the web platform installer? It's a great thing. Yes, it's when it's finished, it'll be what apt-get is on Linux. All right, that's kind of like NuGet and this kind of thing. All right. What you do here, it is the most infuriating piece of software. Has anybody used it before? Okay, so what you want to do is you want to open up the web platform installer, and you want to search there for the HD Insight emulator for Windows Azure. That's a bit of a mouthful. You can tell that that was named by a marketing person, right? Does what it says on the tin. Why web platform installer is absolutely infuriating is that the HD emulator for Windows Azure, can only be run on a 64-bit machine, okay? What do you think happens if you are on a 32-bit machine and you open up web platform installer and you search for that? You'd think so, wouldn't you? You'd think it would do one of two things. You think it would either return it, and then when you went to install it, say, I'm sorry, I can't install it on your machine. Or, better still, it would give you an error to say, well, you're running on a 32-bit machine, so unfortunately you can't install it. It does neither of those two things. Do you know what it returns? Nothing. As if it doesn't exist. As if you typed in the name wrongly, in fact. And you will spend another 5 minutes typing in every variation of those words that you can think are, and then you'll go on to Google, and then you'll search for it, and then you'll find that you were actually right. It is actually called the Microsoft HD Insight emulator for Windows Azure, and you'll still rack your brains wondering why you cannot find it. And then when you search on Google, you'll find a blog post of mine where I rant about this very thing, all right? So, to save you time, if you type this in and you find no results whatsoever, it's because you're on a 32-bit machine and you need a 64-bit machine to run the emulator, all right? But given that you've got that now, who does not have a 32-bit machine right now? Most people do. Okay. You'll be fine then, right? You will see this, you will hit the add and install button, you'll be asked to sign your life away, as is normal with software companies these days. It will install and it will make you look at adverts as it's installing, as most things do these days, right? And when it finishes, it will tell you two things, okay? It will tell you this for a start, that Microsoft HD Insight emulator for Windows Azure has been installed. Yay! It will then tell you that I've also installed the Hortonworks data platform for Windows. This is because HD Insight is just Microsoft's flavor of Azure on Azure. It's flavor of Hadoop on Azure, okay? But really that flavor, it's just Hortonworks data platform for Windows under the hood, okay? So basically what Microsoft have done is they worked with Hortonworks to make the Microsoft version that you can install on your own servers if you want, but if you're using Azure, then what you get is HD Insight. Well, HD Insight is just exactly that same thing, right? But with some nice wrappers on it to make it work nicely with Azure, okay? But you can see here by the emulator that it is just Hortonworks data platform for Windows under the hood, okay? And then when you're finished, you'll get a whole bunch of nice icons on your desktop there that you can play around with your heart's content. It'll let you monitor jobs and stuff like that. We'll have a look at those in a bit. It will also add a shed load of services. All of these ones, right? You can see them when you pop up open your services, you'll see a whole bunch of Apache Hadoop stuff there, all right? And what will happen with this is you will go along using this and you'll be perfectly happy for a unspecified period of time. Okay? And then what will happen is one day you'll pop open the Hadoop command line and it'll say there is no Hadoop here. And you'll go, don't be ridiculous, I was using it yesterday. Right? And you'll pop open the job control browser and it'll say, nope, there's no Hadoop here, and then you'll start to be puzzled as to why it's not there. So you'll pop open this local services box here and you'll see that all those services are turned off. And you go, that's a bit weird, I'm pretty sure that they start automatically, right? I'm pretty sure that that happened yesterday and every single other day I've been using it since I installed it. So what you'll do is you'll go to the first one and you'll hit start and it will not start. And then you'll go and you'll pop open the right click and you will select damn well start, right? And it will not start. And then you go, oh, and you open the log file and you find out that it won't start because of a authentication failure. And you go, what? So you ask it, see across here, it says it's logged on as Hadoop, and you pop open the Hadoop user and you see that Microsoft ever so helpfully, when they installed it, set the password to expire, right? Awesome. Okay, and then depending on what that actually means on your system, depends how quickly it will break. All right? So at that point, you have to go through and you have to change the Hadoop user to not expire the password. Right? Or you can remember this tail, and when you install it, the first thing you can do is to go in and set it not to expire. Okay? Because 9 times out of 10, right, if you don't do that and you just leave it, the day when it doesn't work, you'll have forgotten this story. Okay? And you'll spend hours trying to fix it. Right? It's just because the user has expired. Okay, so that's what Hadoop does. That's how to get it installed. That's the difference between MapReduce and Hadoop. Anybody got any questions so far? No, it's all pretty clear. Excellent. What we want to do is we want to get C# code running on Hadoop. So I'm loath to use the word easiest, right? But the vanilla way to get your machine, to get your software running, and by vanilla I mean the way to write code without anything to do with Hadoop creeping into the code, okay, is to use an API that comes with Hadoop called streaming. And what the streaming API does is it allows any programming language which can read from and write to standard input and output. Okay, if you could write to standard in and standard out with your programming language, then you can use that programming language to write code on Hadoop, right? Now, because we can do that in C#, it means we can actually use C# to write. The gentleman who's a VB programmer, you know, absolutely, you can do the same thing. You can do it with Python, you can do it with Ruby, anything that you can read and write from standard in and out from, right? So we're going to use C# code, and we're only going to write C# code. We're not going to write anything else, okay? Right, now, the word count, right? We've done the canonical example, all right? And since I've never been asked to write word count software, we're going to step away from that now, right? We're not going to do word count anymore. What we're going to do is we're going to predict horse racing results. We're going to do something, you know, actually we're not going to do that. We're just going to kind of, we're going to mimic that work, all right? But it gets us away from word count. So we're going to pretend to predict horse racing results. Anybody who was at my talk yesterday we predicted horse racing results. So if you wanted to be a millionaire gambler, you should have been at my session yesterday, okay? You're a day too late and $1 short. So that's what we're going to, we're going to imitate in this session. So let's have a look at some code. Let's grab this one here is what we want. So to make MapReduce work on Hadoop, what we need to do is we need to create a solution, and we need 2 console applications, right? One to hold our mapper and one to hold our reducer. To make things easy for demonstration purposes, I've called the mapper mapper, and I've called the reducer reducer, all right? As I'll show you later, you don't have to. You can call these things anything you want, right? And I'll show you why later on. But for ease of understanding, that's what I've done. I've called the mapper mapper and the reducer the reducer. So when we pop open here, what we can see is we've got a main, okay? As I said, anything that can read from the console. So we're going to read from the console here, and we're going to keep reading stuff. Basically, this line just says, this code here says, keep reading stuff until there's no more stuff to read, all right? And we're going to feed it a CSV file. And this CSV file is going to have 3 columns, horse, jockey, and course, okay? And then based on the horse, the jockey, and the course, we're going to get some statistics here that are going to tell us whether or not which horse is going to win, okay? And then we're going to output the horse and its stats onto the line. So we're going to write back to standard out. So here, read from, and then write to standard out, okay? As you can see down here, this is our function that actually just does that probability, and actually we're just imitating that. So actually I'm just going to return a random probability, okay, because it's just for demonstration purposes. But when you're actually doing real work, that's the function that you would do your work in, okay? But we're getting away from the Hadoop side of things now, so I'm just going to use a random probability at that point. In the next project, we've got our reducer, and in this code what we're going to do is, again, we're going to do the same thing, all right? We're going to read stuff off of the console until there's no more stuff to read. And then what we're going to do is we're going to split on the tab character, which happened to be the character I used to split my key value pair in the mapper. We're going to get the key, which is field 0, and the value, which is field 1, okay? And then we're going to get the stats that we've got and split them up as well. And then to simulate actually doing a reduction to actually work out a probability based on the stats we've got, I'm just going to sum those up, right? That's all I'm going to do. We're just simulating the work here. And then you can see I'm going to write that out to the console. So 2 things there to note. 1, we haven't written any code that mentions Hadoop at all, right? There's nothing in there that is not just vanilla C#. Okay? And the second thing that you might be thinking about is, well, what's with all this reading from the console and writing to the console? That's all I'm doing. Firstly, how does that stuff get to the console in the first place? And secondly, what happens to it after I write to it? The short answer to that is, what the hell do you care? And the longer answer is, it's Hadoop magic, okay? It's part of the framework that Hadoop provides so that you don't have to worry about all that management of stuff, okay? Using the streaming framework, and if you say, this is my mapper and this is my reducer, Hadoop will fix it for you so that a line of that 64 megabyte chunk will be fed to you onto the console, and you will read it until you have consumed all of that 64 megabyte chunk, okay? And at that point, it will stop. Your reducer, what you tell Hadoop will be your reducer, will be fed the output from mappers until there is no more output, okay? And that mapper output will also be fed to you onto the console, which will read until there's no more input, okay? So that's another one of the benefits that the Hadoop framework gives you. It means you don't have to worry about that stuff, okay? So now we've written our code and we've compiled it, right? And what we have to do now is we have to get it and the data we want it to work with onto Hadoop, all right? So we'll go ahead and look at that now. This is what we want. We want that. And so what I want to do now is I want to say to Hadoop, dear Hadoop, I want to use your file system and I want to make a directory to do this work in. And we'll call it demo because I have literally no imagination whatsoever. And for some reason, this is running really slowly on my machine today. I do believe it's because when I looked at the space available on my hard drive, it was a big red line and it said, not very much. Okay, so I think that's causing Hadoop to run a bit slowly on my machine today, so I do apologize for that. Then I want to say, I want to create another directory. I want this to be in, and that's where I'm going to put my input. I'm going to put my input in there. You used to be able to stack these together like you could do in Linux, but with the latest version of the emulator, they seem to have taken that function off. I used to be able to do make directory demo in, and it would create all that, and now it bitches when you do it. I don't know why you would make that change, but there you go. So the last thing that I want to do is, I want to spell that right for a start. I want to create a demo directory, and here I want to build an app directory where I'm going to put those 2 apps that I wrote. Ding, ding, ding. So now I've created that area, right? What I want to do now is move that stuff up there. So the first thing I'm going to do is I'm going to say, Hadoop, using your file system, I want you to put a file onto Hadoop. And the file I want you to put up there is in here. and it's the horses.csv file. So I want to drop that on here, and I want you to put that into demo in. Thank you very much. And Hadoop goes away and it does that for me. Okay, if this was a real cluster right now, it would be doing that work that I told you about. The chunker would be chunking it up into 64 megabyte chunks, and it would be pushing it out onto the HDFS, and it would be replicating it twice, all right? Because this is on my local machine, it's not doing any of that, right? It's just pretending to, okay? Having moved the data up there, what I want to do now is I want to move the applications. So now I'm going to take my mapper that I've created and put it up there, and I want that to go into demo apps. Did I call it apps or app? Called it app. That was a bit silly. Let me put that up there. Okay, those people who are furiously scribbling down notes, please feel free to do so if that's the best way for you to learn. But remember, video is going to be available. All of this material is going to be available for you to download, all right? So unless it's your preferred way to learn stuff, you don't really need to take notes, okay? So I did that, and I put the mapper up there. So now I want to take the file system, and I want to put the reducer up there. And we can do that, and the reducer is going to go also into demo app. And it's going to do all that, and whilst it's doing that, I'm going to get some water. I'm going to try not to spill it all over the table as I did the last time. Then I poured myself some water. Okay, so right now we've got our data up in the Hadoop cluster, and we've got our applications up in the Hadoop cluster. So what we have to do now is we have to tell Hadoop to do stuff with it, all right? So how we do that is, and I'm going to cheat here, and I'm going to grab this, and I'm going to paste it in here. Now, when I was given this talk, I used to type this command in from memory, and I would get it right about 3 times in 5. All right, so now I just paste it in. The reason it's easy to get wrong is Hadoop is a real stinker when it comes to getting this bit right, this files, this dash files bit. So you can see here, it's this plus the comma. All right, and there's no spaces. You get any of that stuff wrong, and Hadoop just goes, no, not doing it. All right, really annoying. Okay, so now I just paste it in, and because I named my directory something incorrect, I need to go and correct that. So let's just follow the cursor and go to the start, and I can explain what everything is doing here. So what we're saying here is, Hadoop, I want you to run a jar file. Okay, and that jar file lives in this location here and is the Hadoop streaming blah, 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 version number jar, right? So basically you're saying, hey Hadoop, I want you to use the streaming stuff. And Hadoop says, fine, I shall do that. And it says, the files that I want you to use, okay, they live here, all right? They live in app mapper, and they live in app reducer. Those are the files that I want you to use. Now, remember I said when we're writing this code that you could call it whatever you want. I happen to call it mapper and call it reducer just for ease of demonstration, but you can actually call it whatever you like. This is why you can call it whatever you like, because you then have to specify to Hadoop via the dash mapper switch what your actual mapper executable is called, and then by the dash reducer switch what your reducer is called, and that's why you can call them anything you want, okay? Because you then, at this point, you actually tell Hadoop which is which. Then once you've done that, it says, the input that I want you to use is in demo/in. Now you'll notice here that I don't specify a file name. All right? If you don't specify, if you want to use one file in that directory, you specify the file name and it will use that one file. Right? If you don't specify a file name and all of the files are of the same structure, so imagine they're CSV files and they all have exactly the same structure, then Hadoop will just concatenate them all for you, right, into one file and do everything for you. So you can imagine here that this could be, the year, it could be sales for the year, for the month, for this week, right, for this day, and then every single store you've got as a global organization just drops their daily sales in there. Okay? You just run that line, Hadoop will consume the whole thing, provided they're the same structure. Okay? You don't actually need to know what files are in there. All right? And the last thing we have to do is we have to tell Hadoop where to stick its output when it's finished. Okay? Here, for this particular case, when we're using the streaming API, this directory must not exist. Okay? Smartly, the guys who wrote Hadoop said to themselves, if you've spent an hour doing a big reduction, okay, and you've got the result in there, and then somebody comes along and overwrites it before you get access to your results, you're going to be pissed, right? So if you try to specify an output directory that exists, Hadoop will bitch. Hadoop will create you an output for you, named whatever you want it called, and it will stick your output in there, okay? And now that we've specified all of that stuff, all right, we can hit return, and it will chunter on, and it will take a while because for some reason it's running really slowly. So if you've got any questions, now would be a good time to ask them. Yes, sir. Who owns Hadoop? The answer to that is nobody owns it. It's open source software. It's part of the Apache Foundation. And what was the other question? Who owns it? And there was another bit. Okay, so the answer to that question is nobody, right? So nobody owns Hadoop, right? But the Hadoop ecosystem, things that you can use with Hadoop, things like HBase and Pig and all of that kind of stuff, which are also open source. The ecosystem is huge. We're not going to touch on any of those today. But there are companies out there, Hortonworks, for example, and Cloudera are two of them, who say, we will create the best Hadoop installation for you. We think the best installation looks like this. It's got Hadoop, and it's got Impala, and it's got yada, 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 yada. And you can get it from us, and because we understand all the stuff, in fact, some of our guys have contributed back to that, nobody understands this setup better than us, so use our stuff and hire our consultants. All right, so that's how they make their money. They still don't own that code. You can totally download the Cloudera implementation or the Hortonworks implementation, load it onto your cluster, and use that stuff free of charge. Okay? Free as in beer. Okay, so as you can see, it's all finished now, and when it's finished, you get a whole bunch of metrics that you can look at if you're interested in, or you can gather them all up. There are tools out there which will gather that stuff up and present you with nice graphs and everything like that. That answers your question about instrumentation and stuff like that. This is part of what it gets, all right? But we can see now that we've got stuff which is finished, and actually just to make sure, we can go to Hadoop. We can say fs minus cat, and we put it in demo out, didn't we? And have a look at the file. Everything is numbered part something, okay? And it'll be a part followed by a number, which is an incrementation from 0 all the way up to the number of reducers you've got. So if you've got one reducer, like we do, because it's an emulator and it's on this machine, we're only going to get part 00000, okay? If we had 1,000 of these things, we'd get part 0 up to 1,000, okay? And then we could just cat them all together. But here, although we're catting them, actually there is only one thing to cat, all right? But by doing cat part star, if there was 1,000 of these things, we'd still get, we'd get them all catted together and we get 1,000 of them. So again, we don't need to know how many parts we've got. We just do this cat part star. And there we go. So that is all of the output, right? So it's done the work there. We've got horses named 1 through 20, I think. And as you can see, I've got no imagination whatsoever because I named my horses horse 1 through horse 20. And there's the probability that it's going to win a particular race, okay? And that's that done. So let's go back to the slides. I'm not going to lie to you, right? That was a total bollock, right? It was fine not having to write any Hadoop code, okay? But that's a bit of a pain in the neck, right? Having to compile your code and then ship your code up to the Hadoop, ship the data that you want, and then run that jar command saying, this is my mapper, this is my reducer, and over here is my code, and yada, 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 right? it's fine to do that once or twice. It's fine to do it in a demo to show you how the streaming API works, and you know how the streaming API works now, and that's all cool, right? But it would be nice if there was an easier way, okay? And there is an easier way. There is an SDK that ships with Azure, okay? You can NuGet that into your code base, and once you've NuGetted that in, everybody knows what NuGet is, right? Yeah. When you NuGet that into your code base, it means that you can actually, there's a payoff. You now have to start writing some Hadoop code in with your C#. It's not vanilla C# anymore. There's some Hadoop specific stuff in there now. But what it means is you get to work inside Visual Studio, right? And all of the rest of that bollocky stuff, that just goes away completely, all right? So let's have a look at how to do exactly the same thing, all right, but within the SDK. So if we look, that's streaming, that's our problem. This is our SDK one. All right. So now we get our solution, and over here you can see the reference, and we've got the reference here to Microsoft.Hadoop.MapReduce. That's the thing you get in. Those other stuff under there, the Microsoft.Azure and the Windows Azure and the Hadoop web client and all that stuff, that's their dependencies, right? They come in automatically. The one at the top here that I've got highlighted right now, the Microsoft.Hadoop.MapReduce, is the thing that you want to NuGet in, right? Having done that, you have to do three things, right? The first thing that you have to do is you have to create a mapper class, and you create a mapper class by inheriting from mapper base, okay? But actually, this algorithm that I'm going to show you now is pretty much exactly the same as the one that you would use in the streaming API, okay? So here, you're going to get an input line. Instead, now your function will actually be given an input line instead of you having to read it off the console. But again, Hadoop's responsible for that, right? It will feed you that, so you don't really care. And now instead of writing back onto the console, right, what you'll get is you'll get fed in a mapper context. You'll get a context, and you will write to that context instead. But other than that, everything else remains the same. So our mapper, as you can see, is still doing exactly the same thing. It's still splitting up those fields, getting horse, jockey, and course. It's still getting those stats, right? So that probability is still being calculated. So actually, the meat of our algorithm, which is this part here, is exactly the same as it was before. All we're doing here at the bottom is we're writing out onto the context instead of the console. And instead of doing console.writeLine, we're doing context.emitKeyValue, where we pass a key and a value. Okay? The second thing we have to do is to create a reducer class where we actually inherit from reducer combiner base. Now remember when I was explaining how Hadoop works, the map and the reduce, I said there's a combine step that happens on the mapper where it actually runs that reducing function on the mapper before it pushes it across. So it can actually reduce the amount of data that has to push across the network. Well, this is where you define it. If you wanted a combiner to do something slightly different, then there is the option to actually create your own combiner here. But 9 times out of 10, the combiner step is just going to be the same step as your reducer, okay? But for that reason is why you're inheriting here from reducer combiner base and not just reducer base in the same way as your mapper inherited from mapper base, okay? Again, as you can see, the meat of our algorithm is exactly the same. Again, the only thing that's changed is you're going to get an IEnumerable of key value pairs, okay, instead of reading from the console line. And again, you're going to write out to a context instead of writing out to the console, okay, but everything else remains the same. The third thing you have to do is you have to tell, really? That's not what I expected to see. Not to worry. Which begs the question, what code did I run when I rehearsed this earlier on? Anyway, that's by the by. This is still correct. I'll just have to make a correction or two. Here what we're doing now is we're going to create a configuration file. And the configuration file has some of the information that we actually wrote into the command line when we're doing the streaming stuff. Okay, so first of all, it wants to know an input path. Okay, and the input path for us is actually demo in, and the output folder was demo out. Okay, two things to note here. The first thing is we no longer have to specify what the mapper is and what the reducer is, because we inherited from mapper base and we inherited from reducer combiner base, so the framework knows what our mapper is and it knows what our reducer is, so we don't have to tell it anymore. Okay, and the second thing to note is that I've specified demo out as the output, okay? And when I ran it from the command line, it would bitch if I did that. Something to note here, the SDK will not protect you from that, right? The SDK will, and this is just a work of genius, whoever designed this, the SDK will detect that that directory exists, and instead of giving you a warning, it will delete it, right? Nice. So it's worse than actually overwriting, because if it just overwrote, then that would give you an opportunity to actually change the file names of the files that were already in there, and it would be fine. No. It will delete it if it already exists. In fact, if you watch on the screen when I run it, you'll see it detecting that and deleting it because I've used the same path. And then what we have to do is once we have created this config file, telling everybody, you know, the information that we specified in the command line before, what we want to do then is we want to connect to that Hadoop cluster. Okay. Now, because the cluster is on my own machine, right, I just use this URI here, Hadoop being the user ID, blank for password. Okay. If I wanted then to push this out onto my production Hadoop cluster, it would just be a case of changing those credentials there. Okay. What I want to do now is once I connect, I say I want to do a map produce job, and what I want to do is I want to execute this as being the mapper and this as being the reducer using that configuration that I just created. Sometimes you don't want to do the reduction stage. Sometimes you're finished when you've done the map stage. In much the same way as when you're selecting from a database, you don't necessarily always want to group. Sometimes you're just done when you've done the select. If that's the case, then you can just miss that out. You just miss out that parameter. And that signals to Hadoop that you have no reduction stage, and it will just run the mapper and it will be done then. Okay? So having done that, one of the benefits now is we can just sit back and hit F5 and away it'll go. So there you go. Output detected.
You had a map reduce job. It didn't look like a fluid interface. It didn't have the method. It wasn't a method.
No, I'll get back to that in a second. So here, you can see the first thing, it's found that output folder and it's deleted it. Thanks very much, SDK. Yep, great. The next thing it's doing, you can see it's auto-detecting what dependencies I've got, right? So it knows it's going to need a mapper. It knows from the way I've set it up it needs a reducer, goes and finds these DLLs, and it's busy shipping those all up. Whereas previously, we had to move all that stuff up to Hadoop ourselves. Right now, the SDK is sorting that for you. This will be quite slow. So if we go back to your question while that's running. So what was your question?
It's a map reduce job.
Yes.
If it was a method, then it would be a fluid interface, but it's not a method, so what is their property?
Yes. Is the answer to that question. Sorry, I had to decode that in my head. Is it? Yes. And then what you're doing is you're saying, here is a connection to which I want to return this. Let me just put the, that is what that returns. And then once that returns, you say, now I want you to execute it with this mapper and this reducer using the configuration that I defined up here. And we can put in more, I mean, you can look at the other stuff that you can specify here. There's lots of stuff that you can specify here, but the minimum is input folder and output folder. Now let's have a look and see if we're done. Yes. Nope, that's the wrong thing. Damn, thought it was finished. Yes, it's finished. You can see you don't get any feedback unless you ask for it. It just says, here's the job ID, by the way, and I'm done. Okay, there was no problems. Everything was fine. And if we catted that again, in fact, if we run the exact same, because it deleted that and then it redid it, if I run this same command again, we should see exactly the same thing. If we can be bothered waiting for my poor sleepy Hadoop to do its thing. How much time have we got left? Oh, good. So we can see, all right, because I didn't format it exactly the same, we get, in slightly different format, but you can see it's done its trick. Now, the SDK is much simpler, okay? That is a much easier way, and being able to do it from within Visual Studio just by hitting F5 is great, okay? So we don't have to worry about all that moving stuff around, because there's too many, to my mind, that's too brittle, there's too many moving parts there, right? The stuff there you can only get wrong, to be honest. For your information though, the SDK under the hood does exactly what we just did there in the stream. It uses the streaming API because that's the way it's got to work, right? And it did exactly the same thing we did, right? It moved those files. It called exactly that same command line, right? Passed in that exact same dash files attribute, told it with mapper and juice and all that. It did all of that stuff, right? It didn't do anything. It's not like the SDK does something different, right? It does it for you, right? Which is good as far as I'm concerned. All right, let's nip back here. So that is an easier way to do it. And finally, I'm going to talk about how to visualize the results, right? Because right now, we've just got a bunch of text, right? And it would be nice if there was a quick and easy way to visualize this stuff. And the answer to that question is there is, all right? So the quick and easy way of visualizing CSV files that we've got right now would be Excel, right? Just drop your CSV file into Excel. You've got all the charting and everything that you want, right? Wouldn't it be really cool if Excel could read from HDFS? Yes, Gary, it would. So if actually we go here and we go Excel, there we go, if I could spell it right. So we start this up. Yes, thank you very much for telling me that. If we start this up, I didn't ask for that. If we start this up, and we load in a nice, we load in the Power Query tools. Do you know all about Power BI? Have you read about that stuff? Right. It's kind of out with the scope of this talk, but if you go back and you look online for Power BI, okay, you get a whole bunch of nice tools for Excel that you can load into Excel. I'm going to talk about two of those nice tools that come with Power BI today. I'm going to talk about Power Query. So if you go to the Data tab, and this exists now before you do anything, okay? And there's a get external data patch here, and you can get it from Access, from the web, from the text, from other sources. And if you drop down other sources, there's a whole bunch of other sources where you can get data from. And you've got that right now. If you go to Power Query and you do the same thing, and you drop down the from other sources, one of the other sources is from Hadoop, HDFS, right? So if we click on that, the first thing it's going to ask you is, what server do you want me to go look for, right? Well, we're on this machine here, which is win8-dev-pc. So I want you to look there, please. That says, sure, I will go do that. And over there, I've already got a CSV file that I'm going to just simulate as the output from the reducer. From a reducer, okay? So I want to use that, so I click here on this binary tab here, and what it does is it goes off to the cluster and it brings it back, and it says, hey, it looks like this. One of the things to note is you're never going to get column headings on the output from a Hadoop reduce, okay? Because how would it know what would the column headings? How would Hadoop know which mapper output the column headings? So you're only going to get the data. You have to know what that data is, okay? And luckily enough, we do, all right? So the first thing that we do when we're looking at this kind of thing is we're going to change the column names, and we'll change this to time. And this is crime data, we're just simulating here. And we're going to say column 2 is clearly city. And column 3 is the country that we were in. Did I spell that right? Yes. And then we've got a bunch of crime statistics, so we'll just make this up actually. We'll say that this one is housebreaking. You don't have housebreaking in England, do you? What do you call it? You call it burglary, don't you? I can't spell burglary, right? So I'm just going to call it housebreaking. We'll say this one is drugs offences. You can tell I'm running out of imagination now. And we'll call this one taking without the owner's consent, all right? Why did you do that, right? This one is time. Okay. Did I do something weird there, or was that? And this one is taking without owner's consent. It's definitely in that column. Hit return. Thank you, right? I don't know why you did that the last time. All right, so now that we've given it some column headings, right, I'm ready to say, yes, go ahead and use that data. So I'll hit the apply and close button here. And that data will get dumped into Excel. If you've got millions and millions of lines, because it was in a reduced property, a huge map reduce, then what will happen is internally with Power Query, you can create a model, right? And it will create an internal model, and it will go back and fetch the data as it's actually needed, right? And it will let you look at some of it to let you understand what you're working with, right? But it won't try to load 750,000 rows into Excel, all right? But you can still use millions and millions of rows connected to HDFS, right? It'll do that kind of virtual thing. Now, let's close that down. We said we wanted to visualize the data. So already we've got it in Excel, and we can do all the cool things that we can normally do in Excel, like charting and all the rest of it, and that's cool. But I want to demonstrate another really cool tool that comes with Power BI, and that is Power Map. So if we launch the Power Map with the data that we've just brought in, this is where I have to check that we are connected to the internet, or this is not going to work. Yes, we are. Good. Really? Why did you not select the data that I had before? All right, so let's do that. Okay. I don't know why it asked me that. The last time I did it, it said, oh yes, I see you've got data. And this time it says, no, I can't see it this time, you'll have to tell me about it. So the first thing down here is it says, all right, what's happened now is you can see from the bottom left-hand corner, it's gone out to the internet and it's connected to Bing, okay? And because I named my data sensibly, I named the city, the column with cities in it as city, and the column with the country in it as country, then Power Map is smart enough to realize that the city column had cities in it and the country column had countries in it, and it's actually mapped that correctly, okay? But it asks me to confirm. It says, hey, look, if you want to use maps, you have to tell me what the geography is. And down here on the right-hand side, it says, I reckon that the geography you've got is city and country. Is that right? And if it's not, you can change it. And what it says is, I reckon that city is a city, and I reckon that country is a country and region. But if you'd named it something stupid, like column 4, for example, if I just brought that straight in without putting column names on, which I could do, then actually I could say, well, column 4 is a city, or it's any of these other things here, okay? But because I named it in a sensible way, then it's got it right. So I can just click this next button and say, yep, you're absolutely right, it is those things. After that, I can say, right, I want you to graph me the drug offences, the housebreaking offences, and the taking without owner's consent offences. What I'm going to do is I'm just going to grab this legend and close it, because we're a bit constrained for space being on the projector. And now we can kind of log in a bit like that. We can zoom in a little bit, and if we put the labels on, we'll be able to see which parts of the country that is. So Glasgow, Edinburgh, Perth, and Aberdeen, we can see there. We can see that these are the different offences. If I want to see them like that, you can have them broken down like that. And that's really cool, and I didn't really have to do anything. And now, instead of just having a bunch of CSV data, right, I've actually got really cool map data with only a few clicks, right? And that's off my HDFS. But we can go one step further, right? What makes this really cool is we have the timestamp of when the crimes were reported, okay? Now, Power BI has got a function here by, if I say, down here, which seems to have disappeared a bit because of constraints, it says down here there is a time function. If you have a time function and I can say yes, this is the time, then what happens is Power BI will automatically actually apply that time series data. So now if I hit this button here, this play button, I can actually see the clock counting and the crimes as they happen, right? Now, I think you'll agree that is hugely more powerful than just having a CSV file sitting on HDFS. And I created this with just a few clicks. I mean, I created it in real time. I didn't do any cheat stuff here. There's no smoke and mirrors. I did what you saw me doing, right? And I literally did that in 10 minutes, right? In fact, and probably 7 of those minutes were because I'm talking to you, right? I could have done it a lot faster if I was just actually typing. All right, and that is one of the ways that it's just one of the ways you can visualize data. But the point is you can take that data once you've got it and you can visualize it anywhere. But the point I'm trying to make here is that, you know, the good old faithful friend of Excel that you would go to for naturally visualizing data you would do right now if you'd created it on your hard drive or whatever, you absolutely can use that same tool for visualizing data that you've got in HDFS. Okay, so let's pop back to the slides, and we have gotten to the end with the required 10 minutes for questions remaining. Okay?
Which version of Excel was it?
Is it, I beg your pardon?
Which version of Excel?
So for the benefit of people in a video, now I can embarrass myself, and it says which version, gentleman asked, which version of Excel can you use Power BI on? And the answer to that question is, I cannot remember. The one I've got, you can. All right? If you search for Power BI, okay, you can go there. It will tell you which versions. I do not understand why Microsoft just don't go look Power BI for every version, right? Because it's so powerful. Everybody's going to. There will come a day Microsoft have to get it. I think it's because they want you to go to, you know, the Office 365 route. They're kind of pushing that, and this is like, you know, the gateway drug to Office 365. I don't have Office 365. I have Excel 2000 and whatever the most recent one is, right? 13 maybe, is it? And it works on mine, okay? Works on mine, that's all I'm saying. So if you've got the most up-to-date version of Office, it pretty much works. If you've got Office 365, it pretty much works. Under the most up-to-date version of Excel or Office 365, under that, I can't remember, right? Can't remember where you don't get it anymore, all right? But go to the Power BI site, check it out. It'll tell you there if it's available for your version, download it and knock yourself out, because it is a great tool, especially if you're working with bags of data. Right? That is actually an official data science term, by the way, bags of data. Right? Okay, yes, sir.
Is it possible to define multiple mappers and reducers in a same project? Same solution?
So the question there is it possible to define multiple mappers and reducers in the same project? And the answer to that question is kind of, but it depends how you want to use them. You can't just create multiple mappers and reducers and then deploy the whole thing and go do it, right? What happens is you have to have a map reduce job, and then you can do a second map reduce job and then a third map reduce job, okay? So inside your solution, you could have multiple map reduce jobs, but you would have to deploy them as separate jobs, and you would have to do them in the right order.
Can you define the chaining order within the solution?
I do not think so. Okay, I do not think you can do that within the solution. You can deploy the jobs. Well, yes, you can, in as much as you would then write a program. So you see how I had the program, and I said using this configuration, blah blah blah, execute. Right? So you can, now that I come to think about it, but I was thinking about trying to configure it. But actually, all you would have to do is in that program, you would say, define job 1, define job 2, define job 3, and then do execute, execute, execute in that order. Okay? And I don't think the job scheduler, see, the job scheduler might mess up your order, because it might judge that some things are free. But off the top of my head, I think if you just define them, and then specify them, job 1, 2, 3, they will actually run in that order, okay? But I've not tried it.
And they will consume the right output as
Absolutely, because what you would do is, so in the map, you know how I say the input is this, right? What you would do is, the input for job 2 would be the output for job 1. And remember, I think I said to this lady, if you just have the directory, everything in that directory will be consumed, and that's one of the reasons why, so you can chain them together. So it doesn't matter how many reducers you've got, you'll get a part 0 to n minus 1 part files for every reducer you've got. Okay, well, it doesn't matter that you don't know how many that is, because if you just specify that directory, all those part files will be the same structure, so Hadoop will just consume them all regardless of how many there are. Okay? Yes, sir?
So, obviously, I imagine what you would use this for is almost like prototype and building your map and reduce, and then you would...
On the emulator?
On the emulator.
Absolutely, yeah,
Is
for
there
testing and stuff like that.
Is there something after you do that, before you unleash it, the larger set, say you're spinning up into a zero, have you any idea that you can work out that it's the best setup that you would spin up, whether it's 1,000 in the cluster, or how long it's going to take?
So the question there is there any way of basically specifying the optimum way of doing things and knowing how long it will take? So the answer to that first question is that's another one of the problems that Hadoop will solve for you. Hadoop will give you the optimum way of doing that. It will know what the optimum split is and all the rest of it. The answer to how fast it will go, not really. Obviously, it depends on are you using, you're using the whole cluster, how big your files are, but you'll have an idea yourself, because you'll know how big it took you to do certain number of rows on your machine, and you'll know how well your machine looks like each of the other clusters. So you'll have an idea, but there's no real way of knowing, and it won't necessarily take the same amount of time every time anyway. I mean, near enough it'll be the same amount, but it won't be exactly the same amount of time every time. If you are getting back to your specifying your own, now we're getting into more advanced topics, right? And I would say for advanced topics, you want to be using a DSL. So you understand that SQL is a DSL for relational databases. Okay, DSL is a domain-specific language, right? So SQL is a domain-specific language for basically doing what is just set arithmetic. Okay, but you don't want to be worried with that stuff, so you write in SQL, and SQL has a compiler that turns that into the stuff, right? There are DSLs for MapReduce as well, things like Pig, for example, which makes it much easier for you to write complicated requirements in Pig, and then Pig will actually generate multiple MapReduce functions and then run those, okay? So if you're getting above just a very simple MapReduce that you can write here, then you probably look to be using Pig. If you've tried Pig and your requirements are more advanced than the stuff that Pig could do, okay, and you really want to look at this stuff, then there are books and scientific papers out there which tell you whether it's better to do a certain kind of map to get a different kind of reduce, or the difference between map side joins and reduce side joins, and all of that kind of stuff will tell you how many maps you want and how many reducers you want. Okay.
Is there kind of a set of a size of data that you wouldn't really touch Hadoop below? Is there a kind of almost like a threshold?
Yeah, so the question there is, what kind of threshold? When we say big data for this, it's a volume. When we're talking big data in terms of volume, what kind of stuff are we talking about? It's difficult to say, and it depends on what you've got locally and the machines that you've got in locally available to you. But a good rule of thumb is terabytes, not gigabytes. Right? If you've got gigabytes of data, it's not really worth your while. If you start talking about terabytes of data and more, then you're onto the Hadoop cluster. But that's a rule of thumb. Your mileage may vary, but a good rule of thumb is terabytes, not gigabytes. Okay. Same question. What he said. Right. Well, in that case, then what I already said. Okay. Any more for any more? No. Okay. Well, in that case, then I hope you enjoyed the session. Thanks very much for coming. I hope you learned stuff. And if you do have any more questions, then please feel free to ask them while I'm packing up. But other than that, thanks very much for coming, guys. Data scientist, Gary, what we really want to spend money doing and pay you your day rate is to have you count words in a file, right? That has never happened. But for some reason, I guess, it's not really stupid because nobody's ever paid me to write Hello World either. So I'm not sure why this is the canonical example, but this is the canonical example, and it explains the problem quite well. Maybe that's why it's the canonical example. So what I've done here is I've got a string, okay? And you can see here I've been really clever. I've got the word 1 once, I've got the word 2 twice, and I've got the word 3 times, and the word 4 times, all right? And then what we do is we use a nice bit of C# code here just to split that up on the commas. What I want to do is I want to count these words. So this is quite a naive algorithm. I split them up on the commas. I group them together by word, which means it's grouped on the word. Then I iterate through those and I write out the key and the count of the group. So that's basically the word and how many times the word appears. All right, so it's a word count. So when we run this, and if I can actually program, okay, so the one word appears one time, the word 2 appears 2 times, 3 appears 3 times, 4 appears 4 times, and so on. All right, so that works. Woo! We can do a word count. Now, this algorithm is quite naive, all right, and it's constrained in 2 ways. So what's wrong with this code? In which 2 ways is it constrained, or one of the 2 ways it's constrained? It's like, don't ask me questions. It's right after lunch. I came here to sleep. God's sake, you know. All right, so it's constrained, first of all, by memory. All right, so that's one of the ways it's constrained. It's constrained by memory because what I do here is I load in this string, okay, into memory, and then I process it. All right, so if you're standing there and you say, well, what happens if, you know, that input doubles? All right, and what happens if it doubles again and again and again? At some point, you're going to run out of RAM on your machine. The machine is going to fall over. All right, so we're constrained by memory. This algorithm is constrained by memory. So to get round that, we'll say, well, actually, we won't load that string into memory in one go. What we'll do is we'll put it in a file and we'll open a stream on a file and we'll stream it in one line at a time, and that means we're no longer constrained by memory. And that is true, but if I'm here again, I say, well, what happens if you double the input? You say, well, it just takes longer. And what happens if I double the input? Well, it takes longer. And at some point, you say, well, actually, it's going to take 3 days to come back. Now, that is no use, right? You can't set something off and come back 3 days later to get the answer, okay? So we're actually constrained. The second way we're constrained is we're constrained by CPU as well, all right? So this algorithm is naive, it's constrained. Use a language with a funny syntax instead, all right? But everything else is the same. Anybody who does any other languages we've not covered yet? Nope, that covers everybody. Awesome, all right, everybody will have fun. Well, maybe not, but. And then how do I visualize my results? Okay, because it's fine having a big Hadoop cluster to do all kinds of really cool stuff, but then at the end of the day, you still just got a text file full of stuff, right? That doesn't really help you. So I'm not going to spend a lot of time talking about that because this is not a talk on how to visualize data, but I am going to show you one really cool tool, technically 2 really cool tools from Microsoft, which will help you visualize data from an Hadoop cluster very quickly, okay? Literally a few clicks and we'll be good to go. So we will look at that just because it's cool and it helps you see the data and it makes that leap from just a file full of stuff to actually something that interesting that you can see. And then we'll do questions, but feel free to ask questions as we're going along. It's just that questions has to be somewhere on the agenda, so I put it at the end. But feel free to ask questions as you're going along. It's actually easier if you ask the questions as you're going along because then normally I'm actually on the slide or I'm looking at the bit of code you've got the question about. If you leave it to the end, then I've got to rummage around like an idiot trying to find the bit that you're talking about, right? And I usually can't because I'm not really that smart. But shh, don't tell anybody. All right, so demo time. Let's have a look at what problem Hadoop actually solves. What is the point of MapReduce and what is the point of Hadoop? So let's have a look at that. Let's jump along here. Okay, so here's our first bit of code. Now everybody knows the rules, right? That you have to do the canonical example for the thing that you're talking about, otherwise the demo gods smite you, right? So if you're talking about a new programming language, you have to do hello world, right? If you do not do hello world, the demo gods smite you and none of the rest of your demos will work for the rest of your session. Your entire audience will laugh at you and they'll totally slag you off in the attendee feedback, all right? So for some reason, and I have no idea why, the canonical example for MapReduce is a word count, right? I've worked in this area for years now and never have I been asked to count words in a file, right? Nobody's ever said to me, as the same split, we iterate over each of the words just as we did before, but this time instead of counting them, what we do is we output the word itself and the integer 1, so that's going to be our output. So basically what our map function is doing is it's looking at a stream of words and it's going, I've seen that word once, I've seen that word once, I've seen that word once, I've seen that word once. Okay, that's all that's doing, and that's all our map function does. All right? Now, the reduce function then gets that output. And what that reduce function does is it takes in that list of tuples, okay, and it groups them again by the word, Okay, so what it's going to get is it's going to get a word, so say the word the, and it's going to get the word the followed by a string containing 11111111111, right, for every single time the map thing has seen that. Okay, and then it's going to see the word will, and it's going to see 111 for every time the word will appears in the document. And what it's doing there then is it's grouping then on the actual word, and then what it's outputting this time is, again, it's outputting the word itself followed by a count of how many ones there are, basically. Okay? So it's very much the same algorithm. So let's run that and see if it works. Let's select that project, make that startup project, and then click over here and then launch that. And that works. See, so we've got exactly the same output. So it works. But now the difference we've got is that we have two functions. Each can be loaded on to commodity machines, okay, and a number of machines. So we've split up that algorithm into two functions. Two functions are completely independent, okay, we can load them on a number of machines that we want. So now when I stand there and say, well, what happens if that input doubles? I'll just say, well, I'll double the number of machines I've got. Well, what happens if the input doubles again? Well, I'll double the number of machines I've got. And we can do this all day, okay? So now we're no longer constrained by memory nor by CPU, because every machine, once it reaches that constrained level, we'll just add 2 more machines. Okay? And we can stay here all day then going, well, what happens if the input doubles? Well, I'll double the number of machines. What happens if the input doubles? So we've solved that problem, okay? And that is MapReduce. That is the problem that MapReduce solves, okay? It's a problem of what happens, it solves the problem of what happens when you can no longer scale vertically, all right? There comes a point where your input doubles, you can by memory is constrained by CPU. So we need a way around that, all right? And Google actually had the same problem back in the early days when they were indexing the internet. It turns out that indexing the internet, you can't just buy a big box, load it all into memory, okay, and index it, all right? There was a point where you could do that, right? There was a point where you could do that. In the very, very early days of the web, Tim Berners-Lee used to have a machine in his office, right? And stuck to it was a piece of paper. It said, "Do not switch this off. This machine contains the internet." Right? Literally, it was all in one machine. But those days, right, are long gone. So Google had this problem, and what they did was, very smart people at Google, they invented the MapReduce algorithm. And what it does is it takes any algorithm like this, and it turns it into 2 parts. One part being a map, one part being a reduction, okay? And so we'll look at that solution right now. So we're going to use exactly the same algorithm, all right? So here, I'm actually just loading in, I've done the same thing, we've got exactly the same string there, all right? And I do a map on it, and then I do a reduce on the output of the map. So, let's talk about a map. What is a map? A map is a function which takes in any string input, okay? So that's anything that can be defined as a string, so anything that you can serialize down to a string. It takes in a string input, and what it does is it outputs a tuple, okay? With a key value pair, all right? And that key and that value can be anything, okay? But that's what it outputs. And then what happens is the reduce then takes that output, okay? And it takes all of the mapped outputs with the same key and reduces that all down to 1 value, okay? So it's a bit like, it's not exactly like this, but a good way to think about it is in SQL terms, is a select followed by a group. Okay, that's one way to think about it. Is the map being select me some data and group saying and group it together. All right, so it's not exactly like that, but it's a good way to think about it. So in this particular case, because we want to count words, what our map does is, here's our map function. It takes a string input, and look, you can see it's exactly the same. It's not exactly the same, but it's a very similar algorithm to our naive algorithm we've got in here. We do that. Okay, let's get started then. Right, just make sure everybody's in the right place. This is a Hadoop Kickstarter for the Microsoft platform. Is anybody expecting a different talk? Awesome, we're all in the right place then. That's good. So, who here has heard of Hadoop before? Few people, excellent. Who's used Hadoop before? Nobody. Awesome. This is going to be a good session. It wouldn't be the first time I've given a session. I said, who's used Hadoop before? people put their hands up. Who uses Hadoop every day? Same people. It's like, why are you here? Go somewhere else. All right. Okay, so this is me. My name's Gary Short. I am a Microsoft MVP in the C# language. I'm a freelance data scientist engineer. Basically, using those tool sets. Data science, as I've said, if you were at yesterday's talk, data science covers a broad church. It's like saying I'm a farmer. It doesn't really tell you what you do. What I do here is I specialize in 3 things mainly. Predictive analytics. We're not going to do any of that today. I did it yesterday. If you weren't there, you missed it. All right. I also do machine vision. We're not going to do any of that. I do some computational linguistics. We'll do a little bit of that tomorrow when I talk about troll hunting on the internet and how to stamp that out. Do a little bit of that kind of stuff there. So if you're interested in that, come along there. The most interesting part of this slide is the bit at the bottom where you can find my contact details if you want to get a hold of me or ask questions afterwards. Okay? So this is the thing that we're going to cover. These are the things we're going to cover in the next roughly 90 minutes or so. First of all, we're going to look at what problem Hadoop solves, right? Basically, what is the point of Hadoop? What is the point of MapReduce? Okay? We'll define the difference between MapReduce and Hadoop because you find an awful lot of people use those words interchangeably as if they're the same thing, okay? And they're not. Then we'll get on to the important stuff. How do I install it on my dev machine at home so I can play with this cool stuff? How do I get my C# code running on it? Who here is not a C# programmer? Okay, sucks to be you guys. What do you program in? Java. Really sucks to be you. What do you program in? Basic. Visual Basic? Okay, so everything that I'm going to talk about today totally applies to you as well. It's just that you'll